All right, today we're going to take a look at an introduction to exponents and order of operations. Exponents. Exponents is the process of repeated multiplication. It can be represented using a shorthand, a to the power of n, when there are n a's. So if there is an a n times, that is a to the power of n. So first we're just going to evaluate some numbers raised to some powers. So by this definition, if I have 3 raised to the power 4, it means I have 3 times 3 times 3 times 3. That's what it means. Okay? So I do want you to write this part out. After you write out my 4 3s, you can just multiply them in your calculator or in your head, whatever you can do at that point is fine. If you want to do it out by hand, piecewise, that's fine too. And this is 9, and this is 9, and 9 times 9 is 81. Okay, so the next one, I have a fraction, but it works the same way. It says it's to the power of 2. So that means I have negative 2/3 as the fraction times a negative 2/3. So we'll multiply across the top. Negative 2 times negative 2 is, positive 4. And across the bottom, 3 times 3 is 9. Okay, so we're going to see exponents coming up in a little bit later, but just as this is a real quick reminder what exponents do and how we work with them. Order of operations is the biggest part of this, and the reason we talked about exponents is because it shows up in order of operations. So you might remember the acronym Pemdas. Interestingly enough, my daughter and I were talking about acronyms today, and she was going over all kinds of acronyms that y'all know that I have no idea what she's talking about. I don't have a clue. And she asked me, Mom, what are the acronyms you had when you were a child? And I'm like, I don't know. I'm trying to come up with things, right? Pemdas is actually one that's been around a really long time. You've probably heard it before. Sometimes people remember it using the mnemonic device, please excuse my dear Aunt Sally. That's another one that you'll sometimes hear associated with this for those letters. It tells us the order in which we operate in mathematics. And the reason that this is necessary is because if I do one thing and Anna does something else and we come up with 2 different answers, that's not good, right? We need a standardized way that we're all working through the problems the same way so that we know what we're talking about, right? So it's the language of mathematics. So when we're seeing these, the most interesting thing that happens is that when you see PEMDAS, we always see it like this, MDAS. But the M and the D don't matter on their order, and the A and the S don't matter either, okay? So P stands for what? Do you remember? Yeah, parentheses. And then it includes brackets as well. So not just parentheses, but really any grouping symbol. E is exponents. That's why we just talked about them. M and the D or D and the M stand for... multiply and divide. So if there's multiplication and division in the problem, we just work from left to right. We don't multiply first and divide second. It doesn't work like that. It's just doing the multiplication and division as a single step. And then A and S is what? Yeah, it's to add and subtract. And again, it doesn't matter whether we add first or subtract first. We actually work from left to right with any addition and any subtraction that we have present. Okay, ready for some examples? I think that's all that's left. Yep, lots of examples. All right, so taking a look at number 1, we don't see any parentheses, so we just kind of bypass the P step. So the next step is exponents. So that is present in this particular problem. I have the exponent 6 squared on top. So what is 6 squared? 36. So I have 36 on top, and I still have my negative 2 on bottom. So I've cleared the exponent out of the expression, and now the only thing left to do is the division. What is 36 divided by negative 2? It's negative. Negative 18. Yep. Okay, on number 2, I don't have parentheses and I don't have exponents, which means the next thing I go to is the multiply divide step, and I will work from left to right with any multiplication division I see. So if I start at the beginning, I do actually see multiplication first, 6 times 2, so that's 12. And then I have negative 16 divided by 8. So what is negative 16 divided by 8? That's negative 2. And then at the end, I have the plus 2. Now now that we have multiplied and divided, we go on to addition and subtraction, and we just work from left to right. 12 minus 2 is 10, plus 2 is 12. So we get back to 12. Okay, all good? All right, number 3. On number 3, we actually have some grouping symbols. We have 2 sets of them. There's brackets and there's parentheses, so we just start with the one that's embedded the most, right? The inner termed piece, and that would be my 7 minus 8 piece. It's inside of the brackets and the parentheses. So we'll start there. Everything else just gets rewritten until I get to that point. Okay, so in the side of the parentheses, I have 7 minus 8. Negative 1. So if you want, you can write it as negative 1. If you want to change it so it looks like minus 1, that's fine. But we have a negative 1. So we're still working inside of our bracket now because there's still grouping symbols. But we cleared out the parenthesis part. Okay, so inside of the grouping symbols here, we see that we have both addition and multiplication. You guys, you're going to make it really tough for people around you to listen. Thanks. Okay, so we've got addition, we've got multiplication. Which of the 2 steps are we going to do inside the brackets first? The multiplication, yeah. So the 2 part stays the same. You can put the addition if you wish. What is negative 1 times 6?
Negative 6.
Yep, negative 6. You can either leave it in parentheses, or again, you can make the plus negative an actual minus sign. So instead, if you prefer, you can make this look like this. Let me just write it as 6 here. So either a plus a negative 6 or just 2 minus 6 is fine. I still have the bracket, so I still have to work inside the bracket first. So inside the bracket now I have the 2 minus 6, and 2 minus 6 is?
Negative 4.
Negative 4. Again, if you want to put parentheses or brackets around it, you can. But at this point, there's nothing going on inside except the negative 4. And negative 4 times 2 is negative 8. Okay, do you have to show all of those steps? No, you don't have to show every single one of them, but you got to show something. If you jump from here straight to here, I'm going to tell you, you probably grabbed your calculator and put it all in, and your calculator has good order of operations skills too. That's great. Your calculator can have good order of operations skills, but I want to know if you do. So you got to show me some of the steps in between. Maybe not every single one of them, but you have to show me some of them, okay? All right, so this is a big no-no. Don't do that. All right, how about number 4? What is the first thing we're going to do on number 4? Exponents. So there is a 5 squared there, so I still have the 2, I have a plus, and I have a times 3. What is 5 squared? 25. What's the next thing I'm going to do? Multiply. So the multiplication step is the 25. So this is where I started, is the 25 times 3. What is 25 times 3? 75. And now that I have 2 plus 75, I will get 77. Okay, all good? Okay, how about this one? What will we do first? The parentheses. And by saying that, we mean what's inside of them, right? We want to talk about what's inside. I can simplify what is inside that parentheses. Inside the parentheses right now it says 7 plus 2. What is 7 plus 2? 9. So that becomes a 9, and now I have 9 squared divided by 3. What's my next step? The exponent. What is 9 squared? 81. So now I have 81 divided by 3. So this is my last step. What is 81 divided by 3? Yep, 27 is correct. I have 27. Okay, number 6 is interesting. I know you see parentheses in the denominator, but there's actually understood parentheses in the numerator as well. That is, the entire numerator has to be done, and the entire denominator has to be done before we can do anything between them. So there's like this understood grouping because of its location that are there. So if we take a look at the numerator independently, what piece in the numerator has to be done first? The multiplication. So I can actually do that part of it. So I can do 8 plus my 12. And then in the denominator, what step has to be done first? The parenthesis part. So the 6 minus 2. So what is 6 minus 2? 4. So that's 4 squared in the denominator. So while I do have an exponent here, I still also have these grouping symbols. So it's perfectly fine for me to go ahead and add my 8 and my 12 and do the 4 squared at the same time, because these are two separate grouping symbols. What is 8 plus 12? 20. And what is 4 squared? 16. Now that I have a single value on top and a single value on bottom, I can actually take a look at this division. And it is division. I mean, it is. But it's also a fraction. And we've talked about simplifying fractions, which is probably the most natural thing to do at this point. 20 and 16, what do they both divide by?
4.
Yep, 4. And if you don't see the 4 and you just see the 2 initially, just divide it by 2 and you'll see quickly that you have to do it again. What is 20 divided by 4? And 16 divided by 4?
4.
So this is 5/4. It's also equally true if you wanted to write this as 1.25. It's fine. We haven't really done much with decimals, but it's not wrong. If it were something that gave you a repeating decimal, I don't want you to use those right now. That's not a very nice mathematical way to write things with repeatings, but if it terminates it, it's not a big deal. Okay, I think we have 2 more. You ready? Last 2 for today. Number 7. There's fractions involved in this one. What do I do first?
Multiply.
I do the multiplication. So as I'm looking at this multiplication step, you can multiply straight across the top, straight across the bottom. We've talked about that. But you can also reduce along diagonals. So I like to reduce along diagonals. Makes the multiplication part give you a smaller answer when you're done. So that's my preference. The 6 and the 4 both divide by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So I still have my 1/5 at the beginning. And now I can multiply across the top of this piece. So 3 times 1 is 3. And 5 times 2 is 10. So that's the multiplication part of this. 3 out of 10 is in reduced form. I still need common denominators, though, in order to add these together. So what's the least common denominator I could use? 10. So it's not the only common denominator, but it is the smallest one. If I multiply the 5 by 2, I'll get a 10 as a denominator, just like the other 10. So this one ends up giving me 2 out of 10 at the beginning, plus 3 out of 10. And what is 2 out of 10 plus 3 out of 10? 5/10. Will it reduce? Yes. They both divide by 5, leaving me with what?
1/2.
1/2. Thank you so much. 5 divided by 5 is 1. 10 divided by 5 is 2. All right, everybody good? Okay, last one, number 8. What step will we do first?
Divide.
Divide, yeah. We're going to do the division first, right here. So I have negative 44, so I've got the 6 minus still. I have negative 44 divided by 11. Yeah, that's negative 4. So now I have 6 minus negative 4. We've talked about minus negatives before, I think.
Change.
Yeah, so we'll change them both into positives, right? Yep, and then 6 plus 4 is 10. It's probably worth noting that if you wanted to change the negatives up here before we got to the negative 44 divided by 11, you could do it there too. It wouldn't hurt anything. You can think of this as being multiplication of the negative times the negative, so it's in that multiplication step. So you could do it there if you prefer.